So what is the inverse square law? Well, we know that as we move away from a radiation source, the radiation spreads out, and so the intensity gets less as we move further away. So what does intensity actually mean? Well, it's the energy per second which is received on every metre squared of area. To make it easier to understand, supposing you had a metre squared of area and the intensity was 36, that would mean 36 joules per second of radiation energy passed through that 1 metre squared. So intensity is given the units watts, because a watt is a joule per second, per metre squared, which can also be written as 36 watts metres to the minus 2. So let's suppose that the intensity of radiation at a distance r away from the source is 36 watts per metre squared. That means 36 joules of energy are passing through that metre squared every second. So let's double the distance to 2r. You'll notice now that all that 36 watts of intensity passes through 4 times the area. This now means the energy per second passing through each metre squared will be 36 divided by 4, so it will only be 9 watts per metre squared. If we double the distance r, the intensity drops 4 times. That's 2 times the distance squared, which equals 4. So the new intensity is 1 over 2 squared, which is equal to a quarter of the original signal. So now let's look at the intensity 3 times the original distance away, that's 3r. You'll notice now that that initial intensity of 36 is now spread over 9 1 metre squareds. So the energy passing through each metre squared per second is now 36 divided by 9, which is only 4 watts per metre squared. Tripling the original distance r means the intensity drops 9 times. That's 3 times the original distance squared, which equals 9. Therefore, the intensity at 3 times the distance away is only 1 over 3 squared, which is a ninth of the original signal. So it's dropped 9 times. So if we were 4 times the original distance away, that's 4r, the intensity would drop 4 squared, which is 16 times. This would mean the new intensity 4 times the distance away would be 1 over 4 squared, which is 1/16 of the original signal. We can see, therefore, that the signal drops with an inverse squared relationship, meaning intensity is proportional to 1 over r squared, 1 over the distance squared. So how would this look if we plotted a graph of intensity against the distance away? So at a distance r away, the intensity was 36. At 2r away, it was a quarter of 36, which was 9. At 3r away, it was a ninth of the original, so it had dropped down to 4. So at 4 times the distance away, 4 squared is 16, so it was 16 times smaller. So 36 divided by 16 is 2.25. Drawing the best fit curve, you can see the intensity drops rapidly against distance, which can lead to problems when you're trying to transmit signals because the energy drops so fast. The equation you get in your exam is intensity is equal to K divided by r squared, where K is a constant which depends on the substance that the radiation is being transmitted in. e.g. air or water, and also the power of the transmitter. So in this question, we're asked to compare the intensity at y compared with x. Notice that it's double the distance away, and it's only worth 1 mark, so it should be a quick calculation. Twice the distance away means the signal will be 1 over 2 squared, which is a quarter of the original value. Therefore, the intensity IY is equal to a quarter the intensity of IX. So how do we apply the inverse square law to more complicated problems? So intensity I is equal to K, which is a constant, over R squared. The constant depends on the material you're travelling through and also the power of the source of radiation. So if we take R squared to the other side, we have that I times R squared is a constant value, and that's the same all the time. So let's take an example of a radio transmitter. And let's say that the intensity at 2 meters away from the transmitter is 42 watts per meter squared. We could be asked what would be the intensity at a distance of 12 meters away from the transmitter. We know that the signal is going to drop as an inverse square law relationship. Just to get this into context, I've quickly sketched a graph to show you what will happen. Remember, I times R squared is a constant value. So the intensity at position 1 of 2 meters is 42. So I1 R1 squared is equal to 42 times 2 squared, which is 168. So we want to know the intensity I2 at a distance of 12 meters away. So I2 R2 squared is also going to equal 168, as they both equal the same value, a constant value. So I2 is going to equal 168 divided by R2 squared, which is going to equal 168 divided by 12 squared, which is equal to 1.2. Finally, I leave you with the specification points for inverse square law. Read them carefully to check you understand it all.